So now we're going to go through some technical tips that we have found by talking to various customers, things that we pay attention to and we tell our customers to pay attention to when they're working on the machine. In order to do this, we basically have drained the machine, we've turned it on its side, and we have removed a plate that's mounted on the bottom so you can actually see the bottom of the sterilizer. So when working under the machine, you should pay attention to a few things. This is where the heating element comes through, and we have connections to our circuit board for 120 volts AC to come on to the heating element. These are quick connect fittings that over time can oxidize. You need to pay attention to them. Also, there is a series of seals around the heating elements to keep the steam in that you need to pay attention to. If you ever see buildup of any sort of calcium or lime here, or if you actually see water anywhere near this, you need to make sure that those seals have not failed. The way this sealing system works is there is a single fiber O-ring that goes on the heating element bushing that goes inside the chamber. Then on the outside there is a second washer as well as a silver lock washer that's held in place by a nut. All those should be tight and sealed properly. We also have two temperature switches. These are over temperature switches that tell the machine when it has overheated. They are safety devices. They have to be functional. One of the problems we have found is that these connections over time can become oxidized. If you actually are working with electricity, you'll know that oxidation creates resistance. Resistance creates temperature, and you actually can build up a small amount of temperature within these connectors, and we want to make sure that they are not artificially triggering these these thermal switches early. These thermal switches are very important. The reason they normally trigger is because you've run out of water within the chamber, the steam has superheated, the wall of the chamber has overheated to the point that it releases these devices, and you need to figure out why that has happened and where the water has gone. We also have a connection to our main valve assembly. It is a copper tubing with a swaged fitting. This device needs to be sealed. We don't want to see any accumulated calcium or lime anywhere on here. We don't want to see any water accumulated on here. So we want to be sure that we've got this sealed. Now, if you start to see problems with this joint is welded in place, this is not a non-repairable problem. We do not recommend doing any repairs to a sterilizer chamber. You cannot weld them. You need to be ASME certified to do that kind of work. It is not advised. Once these seals fail, this one around here, the chamber needs to be replaced. Please don't try to have them repaired. Okay, so we've now taken the machine, turned it back up in its normal operating position, and we've removed the right-hand panel so that you can see the main circuit board and the various components surrounding it. So we have one circuit board. This is the newer style machine, so we have a smaller circuit board mounted on a metal bracket. Attached to that circuit board, we have a piece of neoprene tubing that is connected to the chamber and allows the pressure to come to the circuit board. This neoprene tubing is held in place by 2 tie wraps. These 2 tie wraps are critical. They must be in place. Even if you're just doing some diagnostic with the machine or testing, these tie wraps need to be here. A leak at this point in the system, even a very small leak, will throw the whole machine's readings off and can be very problematic. Moving right along, we're going to talk about the main circuit board. Since we have 2 different styles of machines, we have 2 different styles of circuit boards. And because they are different sizes and mounted differently, we have to treat them a little bit differently. When you are replacing the circuit board on the newer style M9 M11, you need to send us the mounting bracket that it came with. There were 2 different styles of mounting brackets used by Midmark. We want to be sure that you get the exact bracket that went with that circuit board. So that's something that we ask you to do. On the older style machine, the circuit board sitting over here on the other side, the bracket didn't change. We just ask you to send us the board, and the bracket itself doesn't need to be included. However, on the older style machines, there is a ground path that goes through the metal bracket from the chassis. So if you are going to be removing this circuit board, it's imperative that you also take a look at the mounting bracket, especially the surface between the mounting bracket and the base of the machine. Rust will tend to build up under there. That will break the ground path from the one screw that mounts the circuit board to the bracket. Once that ground path is broken, you'll start having errors with your water level sensor and your temperature probes. A blown fuse on a circuit board, either style circuit board, frequently indicates an external problem to the circuit board. So before you install a new circuit board, you need to ensure that all of the external devices connected to that board are electrically functional, or at least not shorted. You need to check your coils and your valves to make sure that they aren't shorted to the chassis. You need to check the various door opening devices. On the newer style machine, it's a drive motor. On the older style machine, it's a pulse solenoid. Both of those devices can short to case, causing the fuses to pop. We also have a door switch that can become shorted to the case. The heating element itself can also cause these fuses to pop. A cracked, shorted, or damaged heating element allows leakage to the case of the machine, and that can cause problems. Okay, looking at the individual valve assembly on the newer style M9 M11s, and this does apply to the older machines as well. Failure of the fill valve frequently causes water to show up in your chamber when the machine is not functioning. Water leaks past the valve. Failure of your vent valve prevents air from escaping the chamber. The machine won't ever vent properly. When working on these valves, you do not want to grab the internal stems with a plier. Anything that can bend that internal stem will keep the piston from moving freely. That's why we use spanner wrench only to open up these assemblies. You want to make sure if you do go into these valves that everything is clean, that the sealing surfaces are clean and undamaged, and in particular you want to take a look at the sealing surface within this brass block to make sure that it doesn't have any chips in it, or the sealing surface within the top of the bonnet on the vent valve to make sure that it is solid, doesn't have any gunk built up on it, or chips. to ensure a tight seal. Okay, moving to the actual valves. Now, Midmark made their valves in two different styles. The way they changed them over the years was they installed internal to the coil. They installed internal to the coil a full-wave bridge rectifier. These valves run at 120 volts AC. If you install a bridge rectifier within the coil, you immediately take that AC and convert it into a DC voltage, and that means that the internal parts to the valve are different. You cannot interchange the internal parts of an AC valve with a DC valve. The way you know if the valve was full wave rectified is, as you can see on the image, there it will actually say FWR in the voltage specifications for the valve, and that will determine which kits you are going to install in the machine. Also, it will determine what resistance you get when you are measuring the coils. On a AC valve, you will get an actual coil spec, but on the full wave rectified, you will get a 3 to 4 megohm reading for a working coil because you're actually measuring the reverse resistance of the diodes in the full wave bridge rectifier. Before we go any further, I'd like to find out if we've got any questions. How are we doing on questions?
Yes, we do. Looking here at the list. Okay. How can I tell if the air solenoid is working properly?
I think we already did that one.
Okay. Sorry about that. Next. Where is the best spot to place 4 test strips?
Wow, okay. That is a good question. Test strips are used as validation for a cycle. You know, I think I'm going to hold off answering that just a little bit till we get to a further slide. Let's skip over that one just for now, but I promise to get back to it. Are there any other questions?
Yes. Have you heard of trays splitting at the corners for these units? And if so, what's the potential cause?
To tell you the honest truth, I have not. The trays are very robust. I don't really know why that would happen, but I can tell you as part of the manufacturing process that the trays are stamped out of sheets of metal, and that would probably be the weak spot, the thinnest wall spot. So I would imagine it's a mechanical failure. And I don't know that there's really anything that could be done to prevent that. It is, however, something that could be re-welded if you needed to do that, or the trays can also be replaced.
Okay. Another question here. What type of cleaner do you recommend for all American pressure cooker type sterilizers?
Anything that has stainless steel that is not a Midmark, Pelton, or Tuttenauer can be cleaned with non-chlorinated cleaners. There are some brand names out there. If you buy a cleaner that is good for stainless steel appliances, you can use it in a pressure cooker style sterilizer, or you can use it on the frame, door, and chamber of any other sterilizer as long as it's completely cleaned out before you run the machine. Anything that smells like chlorine should never be used on any stainless steel product. The chlorine takes away a layer off the stainless steel called a passivation layer. That exposes the pores in the stainless steel and will directly lead to rusting and corroding of the stainless steel. You should never use anything with chlorine near anything that's made out of stainless steel.
Okay, from this attendee, we've had a third-party service company tell our users to clean these units like the Pelton and Cranes, aka to put the cleaner in the water reservoir. But Midmark's manual says cleaner should go in the chamber only. What are your thoughts on this?
That is exactly correct, and it involves the difference in the chemistry between those two products. One of them actually is a foaming cleaner, and it will do no good if you put the Midmark cleaner in the reservoir. It's not ever going to behave properly. It needs to go in the chamber so that it can actually be activated by the machine and do its job. The Pelton cleaner can go in the reservoir. That isn't a problem, and it is designed for that usage. Of course, even in the Midmark machine, the cleaner eventually gets washed back into the reservoir where it needs to be drained. The water needs to be flushed through the reservoir, and that cleaner needs to be removed from the reservoir so that you don't keep cycling it onto your instruments.
Okay, one more question here. What is the most common problem with the circuit board?
The most common problem on this circuit board there are a series of relays built on the circuit board. Those relays control the flow of electricity to and from the heating elements, the flow of electricity to and from the valves, and the flow of electricity to the door opening device if it's got one. The other common mode of failure on these boards is the pressure transducers. They eventually grow old, they become brittle, they can crack. Those are probably the biggest concerns that we have found on the circuit boards. Yes, you can, on this newer style board that we're looking at here, you can actually build up some oxidation within this connector at the bottom of the board. That's something to pay attention to, but it's not a very common failure. And occasionally we will have some failures within any micro switches that are mounted on the boards, but that's even less common. So there are, in the process of refurbishing these boards, there are a series of parts that are replaced. The relays are all replaced, and we make sure that they have a functional lifespan, and the pressure transducer is replaced as well as part of the refurbishment.
Okay, one more question here. To perform a full refurbishment on either old or new units, which kits do you recommend?
That gets into a little bit more detail than I'd like to go to at this point. It depends upon the level of the refurbishment that you'd like to do to the machine. We do have a planned maintenance kit that includes the door gasket, dam gaskets, and chamber filters. Those all need to be replaced on a yearly basis. But if you're going to refurbish the valves themselves, we need to identify what style valves you got so we can give you the correct internal materials for that valve. Also, you have the options of just outright replacing the entire valve, including the brassware and the housing and the coil, based on the wear of the valve. If you believe that you're having a problem with the brass body of the valve, the only way to actually fix that is to replace the entire valve. Also, if you are working on the newer style valve assembly, we have it available as a complete valve assembly, including both valves and the brass block, or we have broken it down into individual kits. And if you need further information, you need to contact us in technical support, and we'd be happy to tell you what exact parts you need based on your machine's serial number and what you know about whether the valves are full wave rectified or not. Okay, I'm going to go ahead and move along. We have a door motor on this machine. The difference between the M9 M11 and the M9D and the M11D is the D-style machines do not automatically open the door, so you would not have this device. You wouldn't have a pulse solenoid on the original machines either. So let's see, when you're installing the door motor, make sure you get these pins into the right hole. They determine whether it's an M9 or an M11. We're moving on to the front of the machine, to the door itself. We have our door gasket and our dam gasket. The door gasket is reversible, so if you have a slight leak, make sure you give that a try. You can actually rotate it 90 degrees as well, turn it completely around. The dam gaskets came in two different styles based on the version of the machine. There is a version of the M9 that has a metal bracket on the front of it, and there's a separate dam gasket for that. You need to be sure that you're getting the right dam gasket for the right style machine. Now, Midmark sells a wire that they install into the Midmark door gasket. We do not sell that wire, and we do not believe that the RPI door gasket needs the wire. We don't support that. Okay, moving right. Oops, wait, there's one more thing I meant to say. Behind this metal plate, there is a piece of insulation that keeps the door from becoming a heat sink. That piece of insulation gets pressed when you shut the door, and in some situations can become unevenly pressed. One side gets pressed in a little bit more than the other side, and that can cause door leaks. So if you have a door leak that isn't solved by replacing the door gasket, you might want to consider replacing the insulation pad. One thing about replacing this insulation pad, you have to remove the plastic frame of the door and this metal plate, and there is a welded stud on the back of this door assembly. And be very careful when tightening the nut that holds that stud in place. You don't want to unweld it from the door. That cannot be repaired. Also, we have on the machines that automatically open the door, a door spring. This device actually pops the door open. We include two of them in our planned maintenance kit, and if you find that the machine is not popping the gasket strong enough, they can be doubled up. Okay, now we're looking at the front of the machine. This is where the water is put into the machine. Water in sterilizers is very important. You need to be using only distilled water. You do not want to use mineral water, spring water, drinking water. All of those contain dissolved minerals that will accumulate on the chamber of the machine, on the instruments of the machines, and within the valves. The other thing you want to avoid is using deionized water. Deionized water has all its free ions removed, and it will look for free ions anywhere it can find them, including the metal of the chamber, the metal of the tubing, or of the valves. You cannot use deionized water in any sterilizers. When you're filling the water up, it needs to be within the green range on this water level measuring chart, but you do not want to fill it any higher than 1 inch from the top. When the machine vents, it bubbles the water within the reservoir. That can actually cause this water to bubble, and if you fill it up too high, it will spit water out of the top of this tube onto your counter. We have a door switch that actually tells the machine when the door has been closed and sealed. And built into the switch assembly is a piece of spring steel that has a slight bend on the end of it. If that spring steel breaks, you'll get intermittent failures on your door switch. If replacing the door switch doesn't solve your problems, take a look at that piece of steel and make sure that that right angle bend is still in place. Back here in the rear of the machine, we have our temperature sensor. That's the device over here on the right-hand side. It needs to be clean and not have any calcium or lime built up on it. We also have our water level sensor. That's this round disc. The water will fill up until it contacts this device. And we have a series of 2 filters that keep material from the packs or the instruments from getting into the valves. That will extend their lifespans. We replace those on a yearly basis, or they can be cleaned in an ultrasonic cleaner. Okay, again, we talked earlier about what can be used to clean the chamber of a sterilizer. You never want to scrub it with anything that contains chlorine. But if you need to scrub something out of the chamber, there are powdered stainless steel cleaners that you can use with a Scotch Guard pad, and you can scrub off those individual spots as you need to. Also, you can scrub this sealing surface so that we are not having anything sticky pulling the door gasket out. As part of the monthly maintenance, you need to clean the machine. You should be doing qualification testing, sport testing, with runs to be sure that the operator is not overloading the machine or choosing the wrong cycle for what they're putting in the machine, to ensure that not only did the machine function properly, but all of the material within the sterilizer is sterile. We have a heating element on the bottom. The heating element can become cracked. It can become rusted. It can become bent, damaged. You can develop wear spots in it. You want to replace that heating element if you see any of that occurring. You do not want to put a sterilizer on a GFCI breaker because this heating element, it can develop leakage current through the walls of the heating element, through the walls of the sterilizer, and it will trip a GFCI. So the water level sensor needs to be electrically isolated from the chamber in order for it to function properly, in order for it to complete the circuit. The ground path needs to be fully established between the circuit board and the frame of the machine, and there is a seal within that water level sensor keeping it isolated from the chamber that needs to be solid without any leaks. Water level, the temperature sensor needs to be clean. It is a resistive device, and you can check its function using an ohm meter disconnected from the circuit board. Plug your ohm meter into the 2 connections on the cable at the circuit board, and you can literally touch this device and watch its resistance change as the heat in your hand heats it up. Back to the question you asked earlier about where you put your strips. You should always use a tray and a tray rest within the sterilizer. What we are showing here is the tray with our lag thermometer that you are going to use as a testing device to verify that the machine has reached operating pressure. It needs to be elevated off the bottom of the chamber, and you would want to also put, when you are actually operating the machine, any test strips or sport strips or sport tests in the center of the chamber, as close to the center of the chamber as possible, on a tray. You never want to put them on the bottom of the tray rest or a tray assembly, and you wouldn't want to put them up in the top. They really need to be centered within the chamber. Okay, that completes our technical side of the program. I'd like to go ahead and point out that we do have tech support available on our website, as well as one-on-one on telephone free of charge. And we do have maintenance kits for these machines, and you will find information about those in our various posters on our technical support page on our website. I'd like to go ahead and take any questions at this point.
Okay, Neil, we do have a couple questions here. What is the best technique to use to install a door gasket?
In the case of the Midmark, the door gasket goes in very easily, and you can just lay it into the door race starting at the top and putting the bottom of the gasket in. Kind of look at it as a clock. You'd be starting at 12, you'd put the 6 in, and then you would put the 3 and the 9 positions in, and that will spread the material uniformly around the frame of the door race. On the Pelton machines, that becomes very critical. If you were to put a Pelton gasket in starting at 12 o'clock and working around the clock face, you will wind up with about an inch too much material. In order to avoid that, again, you start at 12, you put the top in, then you go to 6, you put the bottom in, you go to 3 and 9, you put the sides in, and you'll have 4 loops of material, and you press those 4 loops in place, spreading the overage in the gasket uniformly amongst the 4 quadrants. Silicon is material that as it heats tends to shrink, so all door gaskets are sold to you slightly oversized so that they will shrink into place. Now on a Tutnauer machine, you also have to pay attention to the shape of the gasket. The Tutnauer door gaskets are slightly wider on one edge than the other. The wider edge, or the keystone edge, the wider side of the keystone, I should say, goes into the door frame. If you put it in backwards, the door gasket will leak and will pull right out of the door race. So you want to put it with the wider side into the door frame.